Section 15 is entitled Tangent Lines and Curve Sketching in Polar Coordinates. Now we talked about earlier how if you have a parameter and you want to find dy dx, you do the following. Now remember, our parameter in polar coordinates is theta. It's dy dx is dy d theta over dx d theta. Now, we know that y is equal to r cosine theta. But r is a function of theta. For example, when they tell you r is equal to 3 minus cosine theta, r is a function of theta. You want to know r, you have to know theta. And instead of calling the function r or y, we generally call it f of, in this case, theta. R is just f for theta. So, dy d theta is the derivative of the first times the second function, plus the first times the derivative of cosine theta, which happens to be minus sine theta. So the numerator is just what I wrote. It's f prime is theta, cosine theta. Something's wrong here. It's a minor error. I can clean it up somewhat easily. X is r sine theta. X is r cosine theta. X is r cosine theta. So I just found dx d theta, which isn't so bad because we need that for the denominator. Sorry about that. So this f prime is theta, cosine of the angle, etc. That is, the denominator is just this equation right here. Now we need to find dy d theta, which is the top. We do it exactly the same way. Y is r sine theta, but r is a function of theta. And if you have y as a function of theta, then you can find dy d theta. First, second. It's the derivative of the first function times the second function, plus the first function times the derivative of the second. That's exactly what the numerator is. And that is how you find dy dx. And in case you ever forget it, that's how you derive it. If you ever forget this equals dy dx, derive it. And I just did. And I'm not even good at this stuff. I just used the product rule. Okay, so now they tell us in problem number 1 that r is equal to 2 plus 3 sine theta. And they even give us the graph. They say, hey everyone, how's it going? This graph looks like that. They want us to find the derivative at a few points. They want us to find the derivative at that point 5, comma pi over 2. And they also want us to find it at 2 pi. And at this high point right there, which is -1, 3 pi over 2. So, I want to find the slope of the tangent line. I want to take the derivative. So I need to find the derivative first. dy dx is equal to Remember, this is f for theta. It's the derivative of f for theta, which is 3 cosine theta, times the sine of theta. Okay? Plus f for theta, which is 2 plus 3 sine theta, times cosine of theta. And all of that, that's just a numerator. In the bottom, you have the derivative of f, which is still 3 cosine theta, times another cosine theta. So I'll call it cosine squared. Minus f for theta, which is 2 plus 3 sine theta, that's f for the angle, times the sine of the angle. So now we want to clean this up. We're going to add 2, there it is, and we're going to add 2 cosine theta, and we're going to add 3 sine theta cosine theta. So we have another 3 cosine theta sine theta. So we get 6 of them. In the bottom, we have 3 cosine squared theta minus 2 sine theta minus 3 sine squared theta. And we can leave it like that. In fact, we will. Okay, so let me erase this. Okay, and we're going to find the derivative at different points. Remember, our dy dx, which is what you see in the right corner, our dy dx is a function of theta. To know dy dx, you have to know theta. You don't have to know x, you don't have to know y, you don't have to know z, you don't have to know any Greek letters, you just have to know theta. And for this top point up here, r theta. I want to know what dy dx at pi over 2 is. The cosine of pi over 2 is 0, and the sine of pi over 2 is 1. Well, when I look in the numerator, in the first term, I see cosine theta. Cosine of pi over 2 will be 0. In the second term, I see cosine theta as a factor. We're going to get 0 plus 0. So I know the numerator is 0. I just have to make sure the denominator is not 0. Well, I know cosine of theta is 0. Cosine of pi over 2 is 0. But then we take away 2 times sine of pi over 2, which is 1, and then we take away 3 times sine of pi over 2 squared, which is also 1. Sine pi over 2 squared is 1. Well, that's not 0. Maybe I don't know what it is, but I know it's not 0. It's negative 5. So the bottom is not 0, so we get 0. Done. Done. Okay, now we go to pi. We want to find the derivative at pi. And this time, the sine will be 0, and the cosine will be negative 1. So in the first term, I have 6 times 0 times negative 1. That's 0. And in the second one, I have plus 2 times negative 1. Well, that's negative 2. That's what I put on top. In the bottom here, I have 3 times negative 1 squared. Negative 1 squared is 1. 3 times it is 3. Minus 2 times 0, which is 0, minus sine of pi over pi is 0, square it is 0, 3 times it is 0. What I end up with is just negative 2/3. Find the derivative and plug in the values. You'll find the slope of the tangent lines. At pi over 2, I can tell you the slope, at 2 comma pi, the slope of that line is negative 2/3. And it looks like at 3 pi over 2, it's going to be 0. Well, what is the sine of 3 pi over 2? The sine of 3 pi over 2, well, that's negative 1. The cosine of 3 pi over 2 is 0. Okay, so now we look at it again. The cosine of 3 pi over 2 is 0. But you know what? This term has a cosine of 3 pi over 2 in it, and so will this one. You add those zeros, you're going to get 0 on top. The derivative at 3 pi over 2, either it's going to be 0 or indeterminate. Can't divide 0 by 0. Now the bottom, the cosine of 3 pi over 2 down here, that's 0. But the sine of 3 pi over 2 is negative 1. So you have negative 2 times negative 1 is plus 2. Minus, you have the negative 1 squared, which is 1 times 3 is negative 3. Negative 1 squared is 1 times 3 is 3. So you have 0 divided by not 0, which is 0. The slope is, like we said, going to be 0. Derivative. Once you plug in the function, times n of the angle plus f of the angle times cosine of the angle. It has to do with the angle. Okay, what if they were to ask you to do the same problem and they tell you that r is 2 times 1 minus sine theta, and they give you the graph again. Graph looks something like that, and they want you to find the slope of the tangent line at 2, 0, and at 4, 3 pi over 2. Again, down here it looks like it's going to be 0, and across here it is going to be a negative slope. So if we don't get these answers, especially the negative slope, we know we're wrong. It might not be exactly horizontal there, but I bet it'll be close to 0. But to be honest, I'm pretty confident it will be 0. Because if I got infinity or 900, I would know something's wrong. Alright, so dy dx. dy dx is equal to, first is f prime with theta. Maybe we could factor distribute. This is 2 minus 2 sine theta. So the derivative of that is negative 2 cosine theta. And it says to multiply by sine theta. It really does. Plus f of theta, 2 minus 2 sine theta. Multiply that by cosine theta. And call that the numerator. Divide this by by f prime of theta, which is still negative 2 cosine theta. Multiply that by cosine theta, so I'll just write cosine squared, minus f of theta, 2 minus 2 sine theta, and times that by sine theta. Maybe it'll be a smart move to put the sine theta in front. Who knows? Now, when it comes to the numerator, I see that I can factor out a cosine and a cosine. In fact, maybe I shouldn't have distributed the 2, because even the 2 factors out. So I factor out the 2. Everything oops, I had the marker in my hand when I did that. Okay, from the 2 minus 2 sine theta, I factor out the 2. In fact, I'll even factor out the minus sign. I'll factor out the sign. So I factored out negative 2 cosine theta, so I'm left with 1 sine theta, minus, the only thing I didn't factor out is 1 minus sine theta. That's the numerator. The denominator, I can factor out the 2 as well. This piece right here is the same thing as, there's the negative 2 sine theta times 1 minus sine theta. So I'm going to factor out the negative 2. And what I'm left with is cosine squared theta minus 2 sine theta, so plus sine theta, minus, what's disturbing me here? Minus sine squared theta right there. Minus plus 2 sine squared. Okay, fine. And the only thing I'll do is, in the numerator, in those big brackets, I'll distribute the minus 1. Sine theta minus 1 is minus 1, but if you take away another sine theta, that means you're really adding sine theta. So, in that case, we'll have 2 sine theta. Now, this stuff you can do to the denominator, but we're going to leave it just like that. The only thing, of course, I will say is negative 2 over negative 2 is history. So let's get rid of it. There is your, there is dy dx. That is dy dx. We'll do the space, or limited space, and we'll erase the middle portion of the board. Don't want to erase the formula on top because we're going to keep using it. So now that we have the derivative, dy dx, I can find the derivative at various points. Like when theta is 0. So dy dx, you really should be writing theta is 0, not just 0, is equal to, well, the cosine of 0 is 1 times the sine of 0 is 0. So 2 times 0 minus 1, the numerator will just be negative 1. Because this here is negative 1. Multiply by the 1 in the front, negative 1. And now the bottom. Cosine of 0 is 1. You square it, you get 1. Plus, the sine of 0 is 0, minus, the sine of 0 is 0. You square it, you still get 0. The bottom is 1. 1 plus 0 is 1. Minus 0 is 1. Final answer, negative 1. And that problem's over. Now we want to, so the slope is negative 1. Right here, the slope is negative 1. right at the point 2, 0, the slope of this tangent line is negative 1. Now, if you wanted to find the equation of this line, you can't say, oh, this is easy. The slope is negative 1 and the point is 2, 0. Well, that's not an incorrect statement, but you better not start using high school algebra to do this, because that's not a rectangular point. Remember, that's 0 radians. And the first number is the radius. It's not x and y. So you would have to convert it back to x and y's. And that was the first thing we did in this section or this chapter. As we said, for example, x squared plus y squared was 4, 2 squared. Then as we converted polar back to rectangular. Or actually what we said was that x is r cosine of theta. R is 2, theta is 0, cosine of 0 is 1, so x is 2. So coincidentally, that first value happened to be right. And y is r sine of theta. And watch this also work. R sine is 0, excuse me. So it's 2 times the sine of 0, but the sine of 0 is 0. And we happen to get 0 as well. So amazingly, it was 2, 0 anyways. So that's not a problem to put on an exam. The student can get it completely right for the completely wrong reasons. Okay, let's find out what happens at 3 pi over 2. dy dx, when the angle is 3 pi over 2. How do we get the cosine of 3 pi over 2? Let me come here. The cosine of 3 pi over 2 is 0. And the sine, if I can sneak it in, the sine is negative 1. So this is 0. And when you multiply it by that, you're going to get 0 on top. And on the bottom, you won't get 0. Because cosine of 3 pi over 2 is 0. Square it, you get 0. But the sine of 3 pi over 2 is, negative 1. Oh, good. And then you take away, sine of 3 pi over 2 is negative 1. You square it, you get positive 1. Now you all know 1 minus 1 is 0. That's not 1. The rest might be minus 1, but that's not 1. The reason you would say that's 0 is because you know 1 minus 1 is 0. But come on, that's not 1. You can count 3. It's negative 1. Negative 1 minus 1, even if you don't know what it is, it's not 0. So 0 over negative 2 is 0. So in fact, the slope of that tangent line was 0. Okay, that finishes that problem. Now, suppose you want to find the horizontal and the vertical tangency of a polar curve. Suppose you come to know that r is equal to 1 plus sine of theta. In fact, let's see if I still have that rule. Good. Okay, so we have the rule in front of us. And right above that line. Okay, and we come to know that r is 1 plus sine theta. In fact, let's do this one first. Suppose you come to know that r is equal to 3 times 1 minus cosine of theta. And you want to find the derivative at the given point. Say pi over 2. Find the derivative at pi over 2. That is, find dy dx and the slope of the graph at pi over 2. Well, you have to use the formula. The derivative formula, dy dx is, remember, this here is f of theta. It's the derivative of f of theta. This 3 just stays there. The derivative of this is sine theta. So that's f prime of theta times theta. And theta squared. Plus f for theta. 3 times 1 minus cosine theta times cosine of theta. F for theta times cosine of theta. The bottom is the derivative of theta, which is 3 sine theta times the cosine of theta, minus f for theta, which is 3 times 1 minus cosine theta times sine theta. And let us clean this up. The first thing I realize is I can factor out as 3. So I get sine squared theta plus this stuff, which is 1 times cosine of theta minus cosine theta times cosine theta. That is, it's that. And in the bottom I see I can factor out as 3 as well. I can factor out that's 3. And the 3 would actually cancel. So I'm left with sine theta cosine theta minus 1 times sine theta minus negative cosine theta sine theta, which is plus. And instead of saying cosine theta sine theta, say sine first. In fact, I have one in front. Now I have 2 of them. There it is. I want the derivative of pi over 2. No big deal. dy dx when the angle is pi over 2. The big deal is to know the sine and cosine of pi over 2. Well, when it comes to sine, pi over 2 is 1. When it comes to cosine, well, if one of them is 1, the other one is 0. Cosine is 0. That means this is 0, this is 0, and that product in the bottom is 0. So in the top, all that survived was 1 squared, or 1. In the bottom, that all that survived is negative 1. My answer, unless I made a silly mistake, is negative 1. Okay, now let's go and find horizontal and vertical tangencies. Remember, when the derivative is 0, you have a horizontal tangency. When the derivative is undefined, that is when the denominator is 0, you have a vertical tangency. But remember, the denominator is 0 and the numerator is not. You can't have them both equaling 0. 0 over 0 is not undefined. So the question says, find the horizontal and vertical tangencies of each curve. And the first curve is r is equal to 1 plus sine theta. Well, I want the for horizontal, I want the numerator to be 0, but not the denominator. Well, let us first find dy dx. Let us find dy dx. So, dy dx is equal to f prime of theta. This is f for theta. F prime will be cosine of theta times sine of theta. Plus f for theta 1 plus sine theta times cosine of theta. And all of this gets divided by the derivative of theta of r, which is cosine of theta, times another cosine theta, cosine squared theta, minus f for theta, times sine of theta. Okay, let's clean this up. The first thing I see is between here and here, they both have a factor of cosine theta. So I factor it out. And I'm left with sine theta plus 1 plus sine theta. 1 plus 2 sine theta. And in the bottom, I don't really see anything I can factor out. So it's cosine squared theta minus 1 sine theta minus sine squared theta. Now, in this case, since I want to set at some point I want to set the bottom equal to 0, I do want to change the way this is. 1 minus cosine squared theta is 1 minus sine squared theta. Remember, sine squared plus cosine squared theta is 1. If you bring this to the other side, you get cosine squared is 1 minus sine squared theta, which is what I just wrote. Okay, so let's continue cleaning this up. The numerator is cosine theta times 1 plus 2 sine theta. The bottom is 1 minus sine squared theta minus another sine squared theta. That's 1 minus 2 sine squared theta minus sine theta. Let me factor out a minus from the bottom. That is, I'm going to multiply the top by a negative and I'm going to multiply the bottom by a negative. So I'll get positive 2 sine squared theta plus sine theta minus 1. Okay, one last thing. If you want to set things equal to 0, it's best to have factors, things that are being multiplied. In the bottom, have a lot of things being added. 2 sine theta plus 1 times sine theta minus 1. That's what you get when you factor. I guess I'm in a jam now. I need to erase the top. In fact, maybe I didn't need to, but that's too late. Let's erase a lot of stuff. So we now have the y dx. We have a horizontal tangency where the numerator is 0 and the bottom is not. And we have a vertical tangency where the bottom is 0 and the top is not. So let's see where the top equals 0. And I guess there's a typo there. What's the minus sign in the numerator? So where is negative cosine theta times 1 plus 2 sine theta equal to 0? Well, it's either when cosine theta is 0 or when 1 plus 2 sine theta is 0. That is when sine theta is negative or half. Well, where is cosine equal to 0? Between 0 and 2 pi. Pi halves and 3 halves pi. Pi over 2. 3 pi over 2. Where is sine of theta negative a half? Well, it's negative. Sine is negative in the third and fourth quadrant. Negative 1 over 2, the hypotenuse. That's square root of 3 negative. fourth quadrant, sine of the angle is opposite over hypotenuse. That's square root of 3. Well, this angle right here is 30 degrees. They're both 30 degrees. So we have 180 plus 30 degrees. That's 210, which is 7 times 30. And 30 is 180 divided by 6. That is 7 pi over 6. The angle is 7 pi over 6. Now, this angle is pi over 6. The whole thing all the way up is 2 pi. Minus pi over 6 is 11 pi over 6. 2 pi, which I'm going to write as 12 pi over 6, minus pi over 6, that gave me the 11 pi over 6. So those are the angles where possibly we have horizontal tangencies. Possible. Just have to make sure that these values do not make the denominator also equal to 0. Okay, so now r is equal to 1 plus sine theta. So if theta is pi over 2, and I have to keep doing this because I have no memory, pi over 2 is 1. So you have sine of pi over 2 is 1. 1 plus 1 is 2. So you have r is 2, and the angle is pi over 2. That's a possible point of horizontal tangency. Now what about 3 pi over 2? At 3 pi over 2, the sign is negative 1. 1 plus negative 1 is 0. So you have 0 comma 3 pi over 2. Our second possible point of horizontal tangencies. There won't be horizontal tangencies anywhere but these 4 values. Okay, what about 7 pi over 6? 7 pi over 6, well, maybe I shouldn't have erased it. That was 30 degrees. 1, 2, square root of 3, and this is negative. So the sign of 7 pi over 6 is negative a half. 1 plus negative a half is a half. So we get r is a half, y means the angle is 7 pi over 6. What about at 11 pi over 6, right here? Well, that's still 30. We get negative 1, square root of 3, and 2. The sign is negative 1 over 2. So you get 1 plus negative 1 over 2, which again is a half. So we have a half, 11 pi over 6. These 4 points, which I'm going to put in the corner, are the possible points of horizontal tangencies. Horizontal. 2 comma pi over 2 is 0 comma 3 pi over 2, 1/2 7 pi over 6, and again a half 11 pi over 6. These are the possible ones. There won't be any others. Now we go on and we look at and try to find the possible vertical points of tangencies. Those are the values that make the denominator equal to 0. The denominator of dy dx. So now I'm going to set the denominator equal to 0. Possible horizontal points of tangency. Just put the box around. Now we want to set the denominator equal to 0. Let me write it higher so I have more space. This times that. We want to know when, if ever, it equals 0. And it is possible it never equals 0. Well, the first one is 0 when 2 sine theta is negative 1. Because I know if that's negative 1, when I add 1, I get 0. But that's, oh my, that's when the sine of the angle is negative a half. But if I'm not mistaken, this one may have just come up. The sine is negative a half. No, I didn't see that from the get-go. Sorry. I thought it was slightly different. But you know what? These were exactly the same. Excuse me, I didn't mean to cross off sine theta minus 1. Those were exactly the same. So, I didn't even need to do some of those angles. In fact, I didn't need to do both of these. But it would have come up in the math anyways. It would have come up that the top and the bottom was 0 at 7 pi over 6 and 11 pi over 6. So it turns out I just need to find out when sine of theta minus 1 is 0. Okay. Well, that's when sine theta is 1. And sine of theta happens to be 1 at pi over 2. So theta is pi over 2. Pi over 2. 0, yes. Okay. 2 sine squared. Okay, hold on, folks. I actually factored the bottom incorrectly from the beginning. I actually factored the bottom wrong. How dare I? The bottom happens to be the following. It's 2 sine theta minus 1 times sine theta plus 1. Let me double check that one. Yeah. Okay. So let us finish this nicely. So in fact, it didn't cancel out on top. In fact, it didn't cancel. 1 plus 2 sine theta. So it turns out that I didn't mean to cross off any of those on the top right corner. So now let's see where the bottom equals 0. Let me stop confusing you. So we have 2 sine theta minus 1 times sine theta plus 1 is 0. Well, that means that sine theta must be a half. 2 times a half is 1. 2 times a half is 1. Take away 1 is 0. On the right side, we want to know where sine theta is negative 1, and that's 3 pi over 6. Now, where is sine of theta equal to 1/2? Where is sine theta equal to 1/2? Okay, sine is positive in quadrant 1 and 2. We kind of just dealt with the half. We dealt with negative a half in the last case. So it's kind of the same. 1 over 2, that's square root of 3. This angle is pi over 6. This angle is pi over 6. In quadrant number 2, that angle is also pi over 6. But in quadrant 2, I want to know what that angle is. I wanted to know what this angle is in red in quadrant 1. This angle. But my answer happens to be right there. It's pi over 6. In the other case, we go beyond what we want. We go to pi, and then we take away what we didn't mean to do, namely pi over 6. Now pi is the same as 6 pi over 6. So that gives me 5 pi over 6. So we get pi over 6 and 5 pi over 6 and 3 pi over 2. Okay. Let's write that up nicely. Pi over 6, 5 pi over 6, that's what theta can be, and 3 pi over 2. If I'm not mistaken, it's been so long, but r is 1 plus sine theta. R is 1 plus sine of theta. Well, the cosine of pi over 6, or the sine of pi over 6 is a half. 1 plus a half is 3 halves. So possible vertical ones will be 3 over 2 comma pi over 6. Now what about 5 pi over 6? What about 5 pi over 6? That's over here. This is negative 1 over 2. So the sine is opposite over hypotenuse. So it's 1 minus a half, which is a half. So we have the angle is 5 pi over 6, and the r is 1 half. So we have 1 half 5 pi over 6. So r goes first. We have 1 half 5 pi over 6. Now we look at 3 pi over 2. Now we look at 3 pi over 2. Let me see what we get there. One plus the sine of 3 pi over 2. Negative 1. So you have 1 minus 1 is 0. So the angle is 0. So, excuse me, r is 0. So 0, the angle is 3 pi over 2. But if the radius is 0, that's not, doesn't matter what the angle is. Okay, you're not going to have a vertical asymptote right there. They can have a vertical tangency if the r is 0. Not going to have it there. So I look at the two sets of possibilities. None of them intersect. That is, I don't see the same 2 points or equivalent points in either of them. I do not see equivalent points. Remember, r theta is the same as negative r pi plus or minus theta. Okay? Think about why those are the same 2 points. I don't see that. I don't see there's no r's that are negative. So you couldn't possibly have that scenario. And the answer is a horizontal tangency points are these 4 points on top, and the vertical ones are just these 2 on the bottom. R cannot be 0. Okay, that finishes that problem. Let's finally erase that. And the next problem is to sketch. Now, what we're going to sketch are called multi-leaf roses. Now, I have a really neat way of doing this. if you came to know, so here is a multi-leaf rose. Okay? If you were able to just identify those points, the ones all at the tip of the roses. If I told you the tip of the roses were here, 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 and here, you should say, oh, this is easy. Here it is, and here, and there. You would just say, well, here it is. Here it is. Maybe another one. There it is. If you just knew where the tip was, it'd be okay. But you know what? Those are the biggest R's that you'll get. Those are the biggest values of R. I mean, for this point right here, R is that length. For this point right here, R is that length. For this point over there, that's R, the longest. There's only 4 points where R is the most. In fact, all this distance and this one and this one and this one, they're all the same. So if we just found out where R is the most, then we'll be okay. So if you had to do R is equal to 2 cosine of 3 theta, the most this R can be is 2. Because the most this is 1, and 2 times 1 is 2. But you know what? If R was negative 2, that's also okay, like negative 2 comma 30 degrees, or pi over 6. What it tells you to do is go out to 30 degrees. This here is 30 degrees, but we extend it in the other direction. That's 30 degrees. We have a number line, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Negative 2 is right there. Okay, that's also okay, because it's 2. This distance is 2, which is what we're looking for. So I want to know where cosine of 3 theta is 1 or negative 1. And we solve that, and we move on to the next problem. Cosine of 3 theta, I want to know when it's 1, and I want to know when it's negative 1. Well, I don't know why this didn't write. Okay. Well, cosine of theta is 1 at 0 pi, and at 2 pi, and at 4 pi, and 6 pi. So 3 theta is 0, 2 pi, 4 pi. Now, I'm anticipating dividing by 3. I'm anticipating dividing by that number 3. So I'm going to stop at 4 pi. Because if I went out to 6 pi and I divided by 3, I'll get 2 pi. I don't want to get 2 pi or above. Now, where is it negative 1? The answer is odd multiples of pi. 1 pi, 3 pi, 5 pi. Okay, we don't want to go above 6 pi. We don't want to go above 6 pi. The next one after 5 pi will be 7 pi. Now when I divide by 3, I get pi over 3 pi, 5 pi over 3. And now I'm in a position to graph this. Okay. Now remember, this one here is really 2. Oh, I'm supposed to divide by 3. I don't know what I was thinking. This is 4 pi over 3. So 2 pi over 3. Well, pi over 3 is 60 times 2 is 120. First, 0, I go out to 2. Here's a circle of radius 2. And 60 times 2 is 120. At 120 degrees, I go out to 2. And 60 times 4 is 240. So right here, I go out 4. Okay? And that gives me 3 leaves. That gives me 3 leaves. Possibly these values over here will give me another 3. Now, remember, this was 0 degrees, and this was 120, and this down here was 240. Well, that's 60 degrees. But you know what? Since I have to go -1, or 2 times -1, since I have to go backwards, if you add 180, you get 240. That is, this angle here is pi over 3, but I have to go back 2. It just brings me back to the same point right there. And pi, at pi, here's pi, I go -2. That means I go along this line to -2, which brings me here. In fact, these 3 won't give us anything extra, and there is your answer. Okay, let's try another one. Drawing the multi-leaf roses is very simple. Set the cosine or sine pi equal to 1 and -1. If you have r is equal to 3 sine of 2 theta, well, just see where sine 2 theta is 1 and -1. Well, sine is 1 at pi over 2. And of course, you can add 2 pi's. So 2 theta can be pi over 2. Now, if you want to add 2 pi, just know 4 over 2 is 2. Add 4 pi over 2. Get 5 pi over 2. Add 2. Get 9 pi over 2. Thing is, when you divide, okay, get 9 pi over 2. Add 2 more, add 2 more pi, you get 13 pi over 2. Well, now when you divide by 2, divide this by 2, you get pi over 4. By 2, you get 5 pi over 4. 9 pi over 4. Excuse me. You get 13 pi over 4. You get 13 pi over 4. Now actually, this one's even too much. 9 over 4 is more than 2. Okay, now, where does it equal to, where the sine of 2 theta equal -1? And that's when the angle is 3 pi over 2. So 2 theta can be 3 pi over 2, 7 pi over 2, 11 pi over 2. But that's going to be too much. Divide by 2, you get 3 pi over 4, 7 pi over 4, 11 pi over 4. 4 goes into 11 more than 2 times. So those are the 4 angles that we're going to deal with. Sometimes they're duplication, sometimes they're not. So we seem to have a lot of pi over 4s. So let me put this down. And the largest will be 3. 3 times 1 is 3. So at pi over 4, I go out to 3. At 5 pi over 4, I also go out to 3. And now here's where it's a little bit different. At 3 pi over 4, that's 3 pi over 4. At 3 pi over 4, I got a -3. And then at 7 pi over 4, I go to +3. Now that I have the furthest parts from the leaves, I am in a great position to draw my multi-leaf rose. There it is. And you know what? I just found 4 points. And the most amazing thing about this was when I was a student, we used to have to go up and do problems on the board. And when I showed my teacher the way I did it, and I made it so easy looking, he said to the class, you cannot do it this way. I am banning this technique. And to be honest, till this day, I have no idea why he didn't like doing the problem easily. Let's do one more graph. That's what this section is about. Plotting or sketching polar graph. You have r is equal to 3 minus 2 cosine theta. So what you do is you make up a table. Since it's going to be a very long table, I'm going to do it horizontally. Theta, let it be 0 pi over 4s, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and close it off with 2 pi. So, and we want to find r. Well, they're all going to be 3 minus 2 times. The cosine of 0 is 1. 3 minus 2 is 1. The cosine of pi over 4 is the square root of 2 over 2. So that's going to cancel out, and we're going to get 3 minus the square root of 2. 3 minus the square root of 2. 3 minus 2 times cosine of pi over 2 is 0. So you get 3 minus 0, which is 3. The cosine of 3 pi over 4 is negative the square root of 2 over 2. The 2's cancel out, and it becomes 3 plus the square root of 2. The cosine of pi is 1. So you get 3 minus 2 times 1. Cosine of pi is negative 1. So you end up with 3 plus 2, or 5. Cosine of pi over 4 is 3 minus 2 times the cosine of pi over 4, which is square root of 2 over 2. So you get 3 minus the square root of 2. 3 minus 2 times the cosine of 3 pi over 2, which is 0. 3 minus 0 is 3. 7 pi over 4, the cosine of that is negative square root of 2 over 2. So the 2's cancel, but negative and negative makes it 3 plus the square root of 2. And the cosine of 2 pi is 1. 3 minus 2 is 1. Just like you should get when it's 0. Now, we connect the dots. We plot the points, and we connect the dots. Plotting multiples of pi over 4, in my opinion, and I don't know everything, that's not a bad way of doing it, I think. Zero, 1 pi over 4, 2 pi over 4, 3 pi's over 4, 4 pi's over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 2 pi. When theta is 0, I go out 1. The most I go out is 5. 1, 2, 3, 4, and then 5. When it's 0, I go out to 1. When the angle is 0, I go out 1. When the angle is pi over 4, I go just before 3. 1, 2, 3. So right before 3, between 2 and 3. At pi over 2, I'm at 3. At 3 pi over 4, I'm a little bit more than 3. At pi, I'm way out at 5. The graph went like that. And due to symmetry, the bottom half is going to be exactly the same. 5 pi over 4, I go a little bit less than 3. 1, 2, a little bit more. 3 pi over 2, I'm at 3. Pi over 4. I want to look at 5 pi over 4 for a moment, please. 5 pi over 4. So here's pi over 4. It's 1 square root of 2. We want the cosine. The cosine is positive. That should have been 3 plus. And the next one, no, cosine. This is negative 1. No, it is 3 minus. Excuse me. This is negative. And so is this, but it's negative. Okay. Yes. So that's correct. And then at 3 pi over 2, it should be 5 again. I think that's the typo. At 3 pi over 2, the cosine is 0. So it's 3, excuse me. So let's go back to the gray marker. It's 3. And then at 7 pi over 4, it's a little bit more than 3. And then it's back to 1. Here, there's the typo. At 3 pi over 4, it should be negative. Oh, but yeah, so it should be plus, excuse me. Okay, and there is your graph. There is your graph. Like a heart. And that completes this section on tangent lines and curve sketching.